Hello, and welcome to Grey Matter's ISV Partner Day 2020. My name is Paul Henwood, and today I'm going to share with you our approach for AI and ways in which you can use Azure AI in your business today. In fact, so many customers are already reaping benefits from their use of Azure AI products. Let me share a couple of examples. ABB used Azure AI products to transform their workforce management solution using cognitive services and bot service to drive efficient communication across thousands of mobile technicians and dispatchers, driving 20% increase in customer satisfaction. TAL is the largest life insurer in Australia and used Azure Machine Learning Service to build and deploy models much faster, which allowed them to review 40 times more cases to ensure customers were receiving the right outcomes. And all of these customers are benefiting from Azure AI. So let's dive deeper into our approach with Azure AI and how we build these products. First, it all starts with breakthrough research, and Microsoft is investing across the spectrum of AI research. Microsoft Research has made significant breakthroughs in the AI categories of vision, speech, and language. In fact, we were the first to reach parity with humans in object recognition, speech recognition, machine translation, and machine reading comprehension. These research breakthroughs are baked and tested at scale as they power the Microsoft solutions such as Office, Xbox, Bing, Dynamics, and more. So when you use Azure AI, you can rest assured that these have been tested at scale by millions of users. For example, with Bing, which has millions of advertisers, we make 280,000 ad recommendations a day on how they can improve their campaign on Bing ads. We feed back on how they should improve their bids for a particular keyword, should they add more keywords that they should search, and really help drive the value to them, helping them to connect with their customers that they want to. In PowerPoint, we rescue people from terrible PowerPoint slides, one slide at a time, by making recommendations based on AI of these terrible bullet points, translating them into really impressive slides that show you what they're trying to say. And Xbox is delivering personalized experiences to millions of users every single day, recommending what different things they should use. In order to ensure these innovations are useful to you, we have 3 investment principles that guide our strategy. Firstly, we want to boost the productivity of developers and data scientists and empower them to build AI solutions faster. And regardless of the skill level of the tools that you're using, we're going to make you more productive on the things that you're doing. If you're a novice at AI or an expert at AI, we have tools that are really going to accelerate your work so you can get more done faster. Secondly, we enable these AI solutions to be deployed at scale alongside existing systems and processes. And most importantly is trust. At Microsoft, we ensure organizations can build with full confidence, knowing that they own and control their data on a platform that adheres to some of the industry's strictest privacy standards, and it has the most comprehensive compliance portfolio of any cloud provider. These guiding principles enable us to fulfill our mission of empowering every developer and every organization to harness the potential of AI. So let's dive into what we can do with Azure AI. There are 3 main solutions you can build with Azure AI. You can build apps that have the ability to interact with users naturally with pre-trained AI models and bots. You can build your own AI machine learning and deep learning solutions. And you can unlock insights lying latent in your content. We'll go through these one by one. Over the course of the rest of the presentation, I'll share with you the latest products that we're bringing across the Azure AI portfolio. And after this session, you should have an idea of which products in our portfolio can help you and your business. Let's get started with AI apps and agents. If you're a developer trying to add AI into your app, the best place to start is with cognitive services. Cognitive services are a suite of very powerful pre-trained AI models that we've built and used in our own applications. These suite of cognitive services across speech, language, and other categories can plug directly into your application, and they combine really well with the bot framework, which allows you to quickly create these very powerful bots. A core part of AI is to create technology that can help machines mimic human ability to perceive the world around us. Cognitive Services offers pre-built APIs that can help your apps understand speech, vision, and language, and integrate these into your apps to deliver immersive user experience. Additionally, we offer web search, which brings you the wealth of human knowledge from the web and allows you to augment your user experience from richer content. We recently added a new category to Cognitive Services. The new decision category goes a step further than observing the world using speech, language, and vision. Services in this category provide user recommendations to enable informed and efficient decision making. We're introducing Personalizer, a new service as part of the decision category. Personalizer uses reinforcement learning, which takes all of the inputs from the users and then matches this to content and experiences that are most relevant to them and what they're trying to do. Personalizer, you can easily embed powerful personalization capabilities in your apps with a simple API. This product is already powering personalized content serving to Xbox users. It takes input from all actions taken by the player and is providing recommendations to millions of users. We also continue to bring new services and updates in other categories as well. In Vision, we launched Ink Recognizer, which enables developers to combine the benefits of physical pen and paper with the best of the digital by embedding digital ink recognition capabilities into apps. You can build on top of it to make notes searchable and convert handwritten sketches into presentation-ready content in a matter of minutes. We also continue to bring new services and updates in other categories. In speech, we're previewing a new advanced speech-to-text capability called conversation transcription that catalyzes meeting efficiency by transcribing conversation in real time. This allows participants to fully engage in the discussion, know who said what when, and quickly follow up on the next steps. We're bringing updates and new capabilities across all of the categories. We've added Anomaly Detector as a new service. We have Neural Text-to-Speech, which adds really natural sounding human voices. The Q&A Maker has been updated to have many more interactions and multi-turn conversations. There's a whole host of new features coming out across the board. And this builds on top of the very comprehensive offerings that we already have. With Cognitive Services, we offer the most comprehensive set of capabilities across speech, vision, language, web search, and now decision for you to use. I talked about Personalizer, but let's talk about exactly how that works with an example. In Xbox, one of the things that we do often as users get to their home screen is make recommendations to them. Here's a game that you might want to think about playing, or a person you might want to connect to, or an activity, or something like that. So we want to make recommendations on that. So you start with all of the things that we know about the user, the games that they've played, their achievements, friends, even the time of day. And you make recommendations on what you think you know about them. But doing it for one person is hard. Now you have to scale that to every single user across Xbox. And if I'm a data scientist, I would start by gathering a data set, thinking through what are the features required to train a model. Then let's put it into production, test it, see how well this does performance-wise, and make recommendations. I would then measure the results, and probably the first version wouldn't work that well. So I'd go back through, iterate, try new features and data, and trying this again, which is a very tiresome process. One of the big changes that we have with Personalizer is using a different form of machine learning called reinforcement learning. Here, you start by simply defining the goal, which is to increase user engagement. And here, the activities we can recommend to the user. You feed that into the Personalizer system, and then you take the same set of things that the user is doing and feed that into the Personalizer. Personalizer is then going to use that to make its own guesses and suggestions of what the user ought to try. It then measures a result and calculates a reward function based on that. And it will do this over and over with all of the different users across the service. Even if you don't have a dataset, say a new game came out that I don't know how well it performs, Personalizer will learn from all of these activities in this reinforcement loop of all the things it can do and make it scale across all of your users and games so that each individual person is connecting with the content that's relevant to them at the time it's relevant for them. And Xbox has been doing this for a while, and there are lots of different personalization systems, but by using reinforcement learning, we think there's a really different approach, and Xbox has seen a 40% uplift in user engagement. But this is one example. There are lots of applications across many industries for this personalizer. Another thing that we've done a lot with cognitive services is that we've really helped customers to take it from the cloud to the edge. So you can take our set of cognitive services and deploy them in containers, which you can run on-prem, on edge devices. You can run it whatever you want to. It's literally the exact same service. The exact same models are wrapped up in a standard Docker container that you can deploy. And customers are telling us this is really differentiated in cases where they have disconnected services, such as cruise liners, or where they can't always be connected, or other areas where maybe data is just too sensitive to share and send to the cloud. Recently, we announced that we have new services in containers, including anomaly detection, speech to text, and text to speech. We have an end-to-end offering for bot development. You can use Microsoft Bot Framework to easily build and test bots, and then deploy and manage them using the Azure Bot Service. And with bot services, we're focusing on two areas. The first one is using open source tools, and we've had over 4,000 commits in the Microsoft Bot Framework from hundreds of developers. Most of those aren't even Microsoft employees, which showcases that we've got a great community involvement in this project. And then on the other side, we want to make it really easy to deploy and manage these bots. We see that with 35,000 active bots and 3,000 new bots being added each week, we're really seeing and getting traction around the creation and managing of these services. A number of new features have been added recently as well. We've got the Bot Framework 4.5 SDK, which adds adaptive dialogues, which makes it easier to do multiple conversations and sub-workflows within a conversation, as well as open source virtual assistant solution accelerator, which shows you how you put a virtual assistant together. And we have skill templates, making it easier to add your skills to this virtual assistant as you're deploying it. Next, we have knowledge mining. Many organizations have potentially valuable information stuck in data formats that are difficult to explore, such as forms, PDFs, and images. And with knowledge mining, you can leverage industry-leading AI capabilities to easily unlock these latent insights from all of your current content. What we do with knowledge mining is we take that data and we ingest it into the cloud, and we run those same sets of cognitive services that we just talked about. We run OCR, entity extraction, key phrase and location extraction, and then we pull all of that together into a graph. And this graph then annotates all of those different documents that the users have. And all of this can be done without any data science experience. We have very positive reaction to cognitive search, and customers have been asking us how they can use the core cognitive search capability in scenarios outside of search. For example, if you have tons of content and you want to have a search experience on top of the content, but also want to visualize it by using Power BI. We've expanded the capability of cognitive search to push the core extractions and enrichments called Knowledge Store into Azure Storage as JSON or tabular files. With this capability, you can connect to your storage and go above and beyond search to surface insights from all your connections to your users. This then opens up very unique opportunities. You can store the enriched metadata that you create with cognitive search and apply it to any variety of scenarios, such as Power BI visualizations, custom knowledge graphs, or you can build machine learning models with new labeled data, or even trigger actions within an application. One data format that most of our customers have is in document or form format. You think about every place that you need to go to fill in some sort of form, be it the dentist's office, be it invoices or receipts that you have to expense. So how do you take all of these forms and get the digital information out of them so you can actually report on it? And there are all kinds of forms in organizations. It tends to be a lot of manual work to move these forms into those meaningful formats, and lots of time is used entering the data to get that right format, slowing down the decision making and incurring costs. To address this, we have Form Recognizer cognitive services. The new Form Recognizer service applies advanced machine learning to accurately extract text, key value pairs, and tables from documents into a tabular or JSON format. With just a few samples, it tailors its understanding to supplied documents, both on-premises and in the cloud. It can also be used to build robotic process automation solutions as well. And the third solution area is machine learning. There are 5 parts to our machine learning portfolio. We have pre-trained AI models, which we covered when talking about the cognitive services. We then have support for popular data science tools and IDEs like Jupyter Notebooks and Visual Studio Code. We have support for popular deep learning frameworks such as PyTorch, TensorFlow, and scikit-learn. We have productive services to empower data science and development teams with Azure Machine Learning Service, Databricks, and machine learning VMs. And we have powerful infrastructure to accelerate deep learning with not just CPUs and GPUs, but FPGAs as well. And our deployment options span the cloud, on-premises, and the edge. So let's dig into how Azure Machine Learning Service can boost productivity for data scientists and developers. If you think about the Azure Machine Learning Service, there are 3 areas we focus on: how we can simplify machine learning for developers, as well as the end-to-end lifecycle management, and how we can make that easier for people as well. We do all of this on the foundation of an open platform. Let's start with how we've simplified machine learning. Machine learning practitioners have all sorts of backgrounds, so why should we expect them to work using the same tools? We've introduced capabilities that simplify model building for any skill level. First, we have business domain experts who know a lot about data, but they don't know much about machine learning algorithms or coding. The new automated ML user interface allows those customers to automatically generate models for their data in a no-code user experience. Next, we have people who are learning machine learning concepts and want to build models themselves, but aren't Python or R developers. These could be IT professionals or statisticians. And for those users, we're offering a drag and drop interface for building models visually with a no-code interface. And of course, we have developers and data scientists who like writing code. They want to build models using the tools they already know. And we're making it easy for them by allowing them to spin up notebook VMs that run Jupyter from their Azure Machine Learning workspace. No matter which of these 3 interfaces that you use to build models, they all use the same backend, meaning all the models can easily be integrated together. In this demo, I will show you how you can easily create a machine learning workspace. I will then give you a tour and an overview of the studio. I will take you through creating a basic classification model without writing a single line of code, using Azure Machine Learning's automated machine learning interface. This classification model will predict if a client will subscribe to a fixed term deposit with a financial institution. With automated machine learning, you can automate away time-intensive tasks. automated machine learning rapidly iterates over combinations of algorithms and hyperparameters to help you find the best model based on a success metric of your choosing. In this demo, I will show you how to create an Azure Machine Learning workspace, run an automated machine learning experiment, then view the experiment details, and then deploy the model. Let's start by looking at the Excel data that we're going to use for this experiment. This is the information about individuals and shows their likelihood to actually subscribe for a fixed term deposit, which is signified by this Y column at the end. And I'll be using this in the experiment as my data source. So in the Azure portal, I'm going to start with creating the workspace by hitting Create a Resource at the top. I will then choose Machine Learning and hit Create. I need to give this workspace a name. I then can choose the resource group I want to deploy this to, or create a new resource group if I don't have one already. I can choose the location I want to deploy this to. I'm going to choose UK South. And then I can choose the workspace edition. In this instance, I'm going to choose Enterprise as I want to use some of those features. I can then hit Review and Create, which will confirm that my workspace name is unique and that everything's okay. Once that's confirmed, I can hit Create. This will take a few minutes to actually deploy and create this resource for me. Once this is deployed, I can go to the resource, and I can then launch the Azure Machine Learning Studio. This studio is designed for data scientists and data engineers to complete their machine learning tasks in an end-to-end and productive way. When you first create the studio, it's a good idea to navigate and start the tour that's made available to you. So if I take a quick tour, you can see we have 3 different authoring experiences, and it's really catering to different skill levels. So I might want to use automated ML as I'm someone who's new to machine learning and I really want to leverage the power of the platform to select the best algorithm for me. Or I might want to use the drag and drop interface because I don't know how to code myself. Or I might prefer notebooks, which is more of a code first experience. Now, regardless of the authoring flow that I choose, all of my assets are created and placed here all in one place. So they're easily discoverable, and I can also share them with other data scientists within my workspace. I can also go and manage some of my resources and my workspaces. Then I could also navigate out to other workspaces if I'm working across multiple workspaces. So in this demo, I will be showing the automated ML feature, so I can select that from the left-hand side, and then I can select Create New Automated ML Run. From in here, I can define a new dataset, and I'm going to use that dataset from that Excel file I showed earlier, which is on my local machine. I can give this dataset a name. I could give it a description if I wanted to, and I can hit Next. When I provisioned my machine learning workspace, it also created an Azure Blob Storage for me, which is where it will store any files that I upload. So I'm going to select that as my destination, and then I'm going to browse to this file on my machine. I'm going to select the file and click Open. This will take a few seconds to actually upload the file. Once the file is uploaded, I can see and preview the settings and the data itself. I can see from having a look at the data that that first row is actually a column header. So I can, from the column headers drop down, I can actually choose all files have the same headers, and you can see the preview of the data will update to actually have that header appearing us at the top. That now looks correct, and I can hit Next. Then I can actually have a look at the columns I want to include in my machine learning model. In this instance, I don't want to use day of week in this instance, so I can select it from the left-hand side, and this will actually exclude it from my model. I can then choose Next. I can then preview and confirm the details to make sure that this is correct, and then hit Create. I can then select this newly created dataset to actually use it in my automated ML run, and I can hit Next. I then need to configure the run itself. I need to give this experiment a name, so I'm going to give it here. I need to choose the column that I want to predict, and you saw from the dataset earlier that I'll be using the Y column. Then I need to create a compute target on which this experiment will be executed. Again, I need to give this a name. I'll then leave the default settings for the size of the VM and the number of nodes and select Create, which will take a few minutes. Once the compute cluster has been deployed, I can hit Next, and then I can select the machine learning task for this experiment. In this demo, we're solving a classification problem as we want to predict if a client will subscribe to a fixed term deposit with a financial institution. So this is the correct selection, and I can click Finish. This will start to iterate through a number of algorithms and parameters, which will score each of these models. The higher the score, the better the model is considered to fit the data. Once the run is completed, I can explore the model by clicking on Models. I can then select the best model, which in this instance is Voting Ensemble, and I can have a look at the actual model details itself. So I can see things like the run ID, the created date, the amount of time it took to execute the model. I can then look at visualizations to see the precision, recall, ROC curve, etc. to help me understand the model performance. I can then select explanations, which will show me which columns had the greatest impact on this model. So I can see from this that duration and employed are two of the biggest impacting columns. If I then like this model, I can choose to deploy it by hitting the Deploy button at the top. I need to give this deployment a name. I can then choose the compute type, which for a high-scale production deployment, I would select Azure Kubernetes cluster. But for testing and development, the low-scale CPU-based Azure container instance is the right choice for this demo. I can then select Deploy. Now I have an operational web service to generate predictions, which I can see by clicking input on the left-hand side and seeing the deployment here. We've also focused a lot on the end-to-end lifecycle management. Most people have heard of the concept of DevOps, how developers are deploying and constantly managing their code. In ML, there's a slightly different concept with MLOps. Things that you do are slightly different. They feel the same, but they're not. You need to consider, what do you check into source control? Is it the model or is it the data? How do all of these come together? And how do I collaborate with other data scientists and developers who are often very different individuals? Let's see how MLOps brings together developers and data scientists to solve these challenges. MLOps fits into the DevOps lifecycle. Most customers begin with data scientists and application developers working in totally different environments. In order to productionize a machine learning solution, developers and data scientists must collaborate efficiently. Most organizations will use a Git repository to enable collaboration and versioning of code. With machine learning, it's not just code that needs to be versioned, but it's also data and training environments. Using Azure Machine Learning, data scientists can track all of these changes, and it works automatically with your existing Git repository. Together with machine learning pipelines, this allows for model reproducibility. Once you have trained a model and it's ready to deploy, you need to validate it to make sure that it works as expected in the production environment and when integrated with your application. Azure Machine Learning's model profiling and validation features help you figure out the right production environment and validate model behavior. Once your model is validated, you need to deploy it. Azure Machine Learning makes this simple by taking care of model packaging and deployment to a variety of endpoints via containers. You can then run these models on the cloud, on premises, or even on edge devices. But the benefits of Azure Machine Learning don't stop there. Management and monitoring of your deployments are also crucial because great models won't stay great if, for example, the input data starts to deviate from the data that was used to initially train the model. Azure Machine Learning helps you manage, monitor, and analyze your models so you know when to retrain them. When models are retrained, you need to build, test, and release your application and model again. Azure Machine Learning takes care of this by integrating with Azure DevOps, so that the retraining automatically triggers your DevOps pipeline for continuous deployment. In addition to getting your models into production efficiently, MLOps ensures responsible use of AI by enabling auditability. Let's say that a customer is denied a loan. They should have gotten due to an incorrect prediction. We need to look at the exact deployment and version of the model at fault, track down the dataset, code, and environment used to train it, and see why the mistake was made. Azure Machine Learning has an audit trail management feature that does this for you. Using the model interpretability feature, you can even look inside your model to see why it behaved the way it did during both training and inferencing. In addition to providing a rich set of MLOps capabilities, Azure Machine Learning allows you to leverage the most comprehensive AI infrastructure for any cloud. In this demo, Manu will show you how you can create a machine learning model in a Jupyter Notebook and deploy this as an experiment into your machine learning workspace.
So let's have a look at how we can access this machine learning workspace through code. So the first thing we do is we connect to the workspace, and because we are running Jupyter Notebooks from the same environment, we can just say workspace from config. Essentially, it's a JSON file which you can store in the root folder of where these notebooks are, and then you can connect just from config, or you can specify the name of the machine learning workspace, the subscription ID, and the resource group, and you can connect it through that method. So let's do that. Let's just connect to the workspace and then create a new experiment. So let's call this diabetes experiment 1 and run this. And as soon as I run this command in the Azure Machine Learning Service workspace, I can see this new experiment. So that's the experiment. It currently doesn't have anything. So let's do the standard machine learning stuff. So let's get some data, and we're getting this data from Azure Open Datasets. This is a relatively new service. You have lots of data sets like weather data, this data set regarding diabetes, also things like New York taxi fare data, and you can use these data sets to augment your machine learning data. So this is a quick view of the data. What we're looking to predict is the Y value. There are lots of features like age, sex, BMI, BP, and then some of the others which I'm not aware of in terms of what they mean. So let's pop the Y column or the label, and then let's train the model using scikit-learn. And what we're doing is we are trying different alpha values here and just running this model, creating multiple models here with each with a different alpha value. And what's happening right now is each of these runs is being stored in the service. So if I go to the diabetes experiment 1, I can see that the runs are being run and they are stored here. So I can go into any individual run and then look at the output as well and the metrics. And we can see the summary over here. So 8 out of 10 runs are completed. And as soon as the runs are finished, so they are finished now, you can just have a look here. By clicking on experiment, it will give you a link to the experiment, and a link to the documentation page on Azure Docs. So we've already had a look at the results in the portal. In order to get the best model, we are just literally iterating through all the models and identifying the one that has the best score for the metric, which is root mean square error in this case. So let's just do that quickly. And now we've identified the best run ID. Now we're going to get access to the model file, and then we're going to download that file. And at this stage, you can literally, with a few more lines, just deploy this model to an Azure container instance or an Azure Kubernetes services instance, and your model is live. So that's how quick and easy it is to productionize your machine learning models once you've built your model.
On top of the CPU and GPUs you're familiar with, Azure is the only cloud with powerful FPGAs for ultra-low latency inferencing. You can access powerful FPGAs from Azure Machine Learning just like you do for CPUs and GPUs for high-speed image classification and recognition scenarios. So we bring the simplified machine learning and the end-to-end lifecycle management together, and all of this is based on the concept of an open platform. And I want to talk a little bit about some of the enhancements that we've made recently on the open platform side. These open platform enhancements is MLflow. MLflow is an open source API that talks through how you manage your machine learning process, the workflow, all of the life cycle of it. This is an open source API, and this is implemented directly in Azure Machine Learning. And you can call these exact APIs and get service tracking and everything that you would expect to come with MLflow. The second is the Onyx runtime. It's a file format that makes it really easy to exchange models from formats such as TensorFlow, PyTorch, to other different formats that you may want to use. It runs really fast. So what we've done with this is we focused on telling a developer, you just need to focus on running it in the Onyx runtime, and you're going to get the hardware acceleration for free. So in the Onyx runtime, which is the open source package, you can take and deploy anywhere, and it's now integrated with NVIDIA TensorRT and Intel's nGraph libraries. So hardware acceleration is coming directly from it. You don't have to think about which one you want to use, just plug the system in and run with the Onyx runtime. And the third thing is an Azure Open Dataset. These are new capabilities that we're announcing that are highly curated datasets that are available to you in Azure, and you can use these to join to your existing data to really simplify and augment your Azure Machine Learning processes. And these datasets of different types really expand and flesh out the data that you can use to train your machine learning models. So with Azure AI, we really have a complete set of services, from the AI apps and agents to knowledge mining, and finally our machine learning service. There are many Azure AI customers doing great things with AI, and you can find case studies from most of these customers listed here, or you can listen back to previous events such as Ignite to hear directly from these customers about their experiences and hear more about the great things that they've built. As a next step, please visit learn.greymatter.com to learn about all things data from their online training platform. And please reach out to Grey Matter to see how they can help you with analysing your Azure spend, with remote discovery workshops, Azure health checks, or how they can help you implement AI in your solutions.